All right, folks, we are going to cover the law of sines, which is concept two, part one of concept two. The other part is the law of cosines, which will be covered in the next video. So the law of sines is really helpful when we have to, find the values of the sides or the angles of a triangle when it's not a right triangle. So it's really helpful in that case. So the law of sines shows the proportional relationship between angles and their opposite sides. It can be used to find the side lengths and angle measurements for any triangle, so that does include right triangles, but we learned that with right triangles we have the other trig functions that we can use, so there's easier ways to find them, but it does work for right triangles as well. But the law of sines essentially states that if I have a triangle like this one on the left here, that is ABC, the capital letters are, they represent the angles, and the lowercase letters represent the sides. The ratios that can be made are equivalent. So we would say that the sine of angle A divided by the side length of A is equal to the sine of angle B over the side length B, which equals the sine of angle C divided by the length of side C. What we'll do is we'll do a few problems that look at this relationship. So either we're going to be looking for angles or looking for side lengths in these problems. So in our first example, we have a triangle where we have two of the angles and one of the corresponding sides, and we need to find the other corresponding side. So we can label our triangle with A's, B's, and C's. It doesn't matter which variables you choose, just make sure you're consistent. For example, if I said that this one was A, this 71-degree angle was A, then my x side would be little a, and if this angle was B, then my 12th side here would be little b. It's the opposite angle and side of the triangle. So what I would do now is I would take my ratio, sine A over A equals sine of B over B. So what I'm going to do is I'm going to begin to plug in these values, the ones that I know, so that way I can find the one I'm looking for. So sine A, well, angle A is equal to 71 degrees. And side A, we don't know what it is. And sine B, well, sine B is 35 degrees. And little b is 12. Our side length is 12. Now, this looks like a proportion, which it is. And when we learned how to solve for proportions, we learned that we can cross multiply. So what we're going to do is we are going to cross multiply and get x by itself, and that'll give us a route to calculate for that missing side. So I end up with x times the sine of 35 equals 12 times the sine of 71. From here, I want to get x by itself, and since I'm multiplying by the sine of 35, I need to divide by the sine of 35 on both sides. And just remember that whenever you have the sine of an angle, that just represents a number in your calculator. It's when you put it into your calculator, you get a decimal. It's it could be like repeating, it could be not repeating, it could be positive or negative, and that's okay. It just represents a number, and so we can treat it like a number. So if I have the sine of 35 over the sine of 35, well, those things cancel each other out. So my final calculation to find x would simply be 12 times the sine of 71 over the sine of 35. You would take this and put it into your calculator, and you would roughly get 19.8 units. So our side length A, or x in this case, is equal to 19.8 units. Let's take a look at another example. Now, here, we're going to do the same process with our triangle, but first we need to label the sides. So, and the angles as well. So say that this is A, and this is side length A, and this is B, and, well, that's side length B, and this is C, and this is side length C. Well, it doesn't look like I have pairs of angles and sides and corresponding sides. But I know that the angles in a triangle add up to 180 degrees. So I can find angle C. So if I have 53 degrees plus 96 degrees, that gives me 149 degrees. So 180 minus 149 is 31 degrees. So that's really helpful because now that I know that this angle is 31 degrees, I now have corresponding sides. I have the A's and I have the C's. Well, I know that sine of A over A is equal to sine of C over C. From here, I just need to plug in my values. So sine A is 90, so sine of 96 over 27 is equal to sine of 31 over x. And this is very, very similar to what we did in the previous problem. I would cross multiply here. Cross multiply. So the sine, so 27 times the sine of 31 is equal to x times sine of 96. Now, just like before, we're going to get rid of the sine of 96 by dividing on this side, which cancels them out. But because I do it on one side, I also have to do it on the other. So finally, x is equal to 27 sine of 31 divided by the sine of 96, and approximately that equals to 14.0. So that side length gives us, that side length we need to look for is approximately 14.0. Now, the past two problems, we are given enough information to find a missing side. But we can also use the law of sines to find a missing angle. And that's what we're going to do in this next example. So we're going to go about labeling the diagram just like we did before. So I'll say that this is angle A, and this is side A, and this is angle B, and this is side B. Great. So we have the information we need. We would just have to set it up. So sine of A over A equals sine of B over B. Now, I'm going to plug in my values. So angle A is x, and side A is 21, and angle B is equal to 61 degrees, and the side length is 24. Well, just like before, if I want to get rid of something, I have to do the opposite operation. So since I'm dividing by the 21, I need to multiply by 21. So now the sine of x is equal to, where'd the 1 go? The sine of x is equal to 21 times the sine of 64 divided by 24. Now, this is where it gets a little tricky. Because I could find 21 times the sine of 61 divided by 24 in my calculator, but I have to do one extra step, which is when I want to find my angle x, which is here, x degrees, I need to use my inverse functions, my inverse trig functions, specifically in this case, inverse sine or arc sine. So if I wanted to find x, I would do the inverse sine of this whole ratio. Okay? I'm going to take the whole ratio and figure out what that is and put it into my inverse sine calculator, or inverse sine function. So just to highlight this, I'm taking this whole thing and substituting it right here into my inverse sine function. So you can do all this in your calculator. You would find the 21 times the sine of 61 over 24, and then take that whole thing and put it in the inverse sine function. And that would approximately be 49.9 degrees. So the angle that we are finding there would be approximately 49.9 as rounded to 1 decimal place. That is the law of sines. Stay tuned for part 2 of concept 2, which is the law of cosines.